Welcome to 13Cubed. In this episode, we're going to perform a comprehensive walkthrough of a Windows memory forensics challenge created by 13Cubed for XINTRA. If you're not familiar with them, XINTRA is a cybersecurity training company founded by Lena Lau, whom many of you may know as Inverse Costs. In addition to training, they offer a product called XINTRA Labs that lets you gain hands-on experience with APT cases based on real-world threat actor behavior. The labs are affordable and highly realistic, so when Lena reached out and asked if I was interested in contributing, I was happy to say yes. This lab includes 2 images, a workstation and a server, along with questions about each that we'll tackle using MemProcFS. So over the next hour, we'll walk through each question together, and I'll show you how I would go about finding the answers. So buckle up, grab a snack, and let's get started. Let's start with the workstation image. To do that, we'll run memprocfs.exe, and we'll need to use -device to point to that memory image. On this machine, that's going to be within a folder called lab on my desktop, and the name of the image is just workstation.vmem. Next, we're going to use -forensic1. The -forensic option is going to tell MemProcFS to use the built-in find evil checks that are going to surface a lot of common low-hanging fruit, a lot of common anomalous behavior that would be very easy to pick out of memory. So that's just going to automate a lot of those checks for us and really is a very, very large advantage to using MemProcFS. So let's use that. And the number 1 is just going to tell it to use an in-memory SQLite database, which is almost always the option I use. And then lastly, we're going to use -license -accept -elastic -license -2.0. This is going to tell MemProcFS that we want to use the built-in YARA rules. So this is going to be very important because if we accept this elastic license agreement, we can use those YARA rules and further automate a lot of checks for common things that you might find in memory, common types of malware. Things like Cobalt Strike, for example, which have YARA rules that are already built into MemProcFS. So by using this option, we're telling MemProcFS that yes, we do want to use those YARA rules in addition to our normal find evil checks, which are provided with the -forensic option. Okay, so when we press enter, notice that we do get this information here that says plugin Python initialization failed. This is fine. You don't need to have a Python environment configured. That's completely optional. Notice that we do have our mount point right here of M:, and we are good to go. Now, behind the scenes, that forensic process that has been kicked off by us using the -forensic1 parameter here is actually running, and it's going to take somewhere between 1 and 5 minutes, depending on the complexity of the memory image, how large it is, and so on. So that's running in the background, but that's fine. All we need to do is keep this window open. We can minimize it, and we'll bring up Windows Explorer. We'll click on this PC, and we can see our M mount point right here. So let's click on that, and now we're looking at the root of the MemProcFS virtual file system, and we can start answering our questions. The first question is, what is the host name of this device? With almost every one of these questions, there are going to be multiple ways that you can go about answering them. In some cases, I'll show you more than one way, but just know that you may find an alternative method that might be more complex or less complex than what I'm showing you. But as long as you arrive at the same answer, it doesn't really matter. So with that said, what is the host name of this device? Let me first show you the longer way. So what we're going to do is drill down into the registry, because remember, MemProcFS is actually going to recreate as best it can the registry based on the memory that's available here, which is pretty awesome. So let's go into HKLM, System. We're going to go into Control Set 001, Control, computer name, and finally, the computer name value is right here. But notice that we do have a computer name.txt file right here, and that's just going to be the easiest way to get the answer. So let's double click on this, and as you can see, the computer name is right here. And that's the answer, BLD-RM202-14. But there is actually an even easier way to jump straight to the answer. So let me show you that. Let's go back to this PC. Let's click on M again. Now we're in the root. And all we have to do is actually go into the sys folder or directory here. And within sys, we'll actually find a text file called computername.txt. You can see it right here. and the information is right there. It's already extracted out for us. So that's another way to get the same answer. And as you can see, that's a bit easier because it just pulls it out automatically and sticks it in the root of sys. But there you go. There's the first question answered. Now let's go back to the root again and look at the second question, which is, what is the name of the domain to which this workstation is joined? In this case, I'm not aware of the domain being extracted out into an individual text file within sys. So what I'm going to do is actually go through and traverse the registry. And to do that, we'll go back into registry and we're going to go into our path where we would normally find this if we're performing on-disk forensic analysis. We can go into HKLM. We can go into System. We're going to go back into Control Set 001, Services, TCP IP, which you'll need to scroll down and find. It should be here somewhere. There it is, TCP IP. And then under TCP IP, we'll go into Parameters, and then Domain, which is right there. But again, if you scroll down, you should find domain.txt, which is just a text file representing that value. So if we double click on domain.txt, then you should see the domain, which is right here. You can see it as kgdistribution.qm. So that is the answer to the question right there. And once again, just look at the path within Windows Explorer. You'll notice we're under M:registry HKLM system control set 001 services TCP IP parameters. As a reminder, if you go to 13cubed.com and click on the downloads link, you'll actually find a registry cheat sheet that's going to have a lot of these locations provided for you. So don't feel like you have to memorize all of these registry paths. Admittedly, a lot of them are committed to memory for me because I just reference them so often. But again, that's not entirely necessary. You have a cheat sheet available to you, or you could just easily Google and find the location that you're looking for. And that's all there is to it. So that's question number 2. Okay, question number 3 is, what is the username of the primary user on this device? The easiest way to answer this is to go ahead and go into M, and from here, let's go into sys, and then within sys, we'll find users, and then finally, users.txt. And if we click on users.txt, check it out, patricia.bethel, which is the username, and you can see the SID right here, which ends with RID1128. So the answer to our question is indeed patricia.bethel. And all we had to do was reference the users.txt file, which once again was located within msys users and users.txt. The information was extracted out for us, and that's all there is to it. Okay, once again, let's go back to the root here and move on to the next question, which is, what is the IP address assigned to this device? Now, let me show you the long way first, which is going to be to traverse the registry. So we could go into the registry here, and then there's going to be quite a long path that we need to traverse. So let's go into HKLM, System. Once again, we're going to be in Control Set 001, Services. We're going to go back to TCP IP, Parameters, Interfaces, and then finally, we have 3 different interfaces here represented by these GUIDs. And you can click on each one, but the actual one that you're going to be looking for here, I think, is going to be the last one, which is the ED key that you can see right here. And if we scroll down, what we're looking for is DHCP IP address. But as you would imagine, there is a text file called DHCP IP address as well. If we scroll down, you can see that right here. Now, if we click on that, finally, we can see the value, which is 192.168.8.12. So that's going to be the answer to our question. And just to recap how we got that, the full path of where we went, you can find by clicking up here in the Explorer window. But notice that it's under System, Control Set 001, Services, TCP IP, Parameters, Interfaces, the Interface GUID, and then finally DHCP IP address.txt. Now you may be wondering, well, how did you know to go to that particular third GUID? Well, if you take a look at it, that's going to be the only option because you don't see the DHCP IP address.txt file here or the value. And the same is true for that first GUID as well. So it has to be this particular GUID. And that's all there is to it. So that's the answer to the fourth question. Once again, let's go back to this PC and go back to the root here. And now let's move on to the fifth question, which is, what time did the user open the malicious phishing email? Now, this is admittedly a bit of a contrived scenario because in this particular challenge, the email was actually opened as an offline .eml file. So I'll tell you that as a hint, because that's going to make it a lot easier. You're not really looking for an artifact of an email within like a PST file or an OST file or anything like that. It's literally an EML file that you're looking for in this particular lab scenario. So how would you find that? Well, let's talk about the forensic folder that you see here. And remember, when we use the -forensic1 option, we told it to automate a lot of those checks. And by doing that, this forensic folder is going to have a lot of excellent information in it within Find Evil. But also within the forensic folder, you're going to have a CSV folder that you can see right here. And within it, you're going to have CSV timelines that are automatically created for you. The specific timeline in which we're interested is called timeline_ntfs.csv. Now, on my system, I've associated CSV files with Timeline Explorer, which is something that I often do on my forensic analysis machines, and I recommend you do the same. It just makes it much easier. And Timeline Explorer is going to allow us to browse the CSV file. If we maximize this, we can see all of the data here. So what we're going to do at this point is literally just start doom scrolling and looking for context around what we're seeing around the time frame in which the events took place. Remember, I told you that the suspicious phishing email is going to be in the form of an EML file. So what we could do is we could filter this and just go directly to that file if we can find it. And to do that, we could just type in, for example, EML and see if we get lucky here. And in fact, we do. Notice the actual path here, which is under /1/. That's actually going to be C:, users, patricia.bethel.kg distribution, documents. And then under documents, notice we have that EML file, action required IT system upgrade.eml. Now, if we scroll back over to the left side here, we can actually see that if we sort by time, so they're in chronological order, if we go up here, we're actually going to see that there's a timestamp of 16/31/58. Notice the action says CRE for creation or birth. So 16/31/58 on 2024-0818 is indeed the answer. This format, as you see it displayed here with the YYYY-MM-DD in that format, along with the timestamp, that's how you need to answer the question. And that is the answer right there. Okay, so let's go ahead and close this and proceed on to the next. Once again, we'll go back to the root. And our next question is, what is the name of the remote administration tool downloaded and used to gain a foothold onto the system? Well, one of the easiest ways to answer this, in my opinion, is to start by looking at network connectivity. If there was some sort of remote administration tool in use, then chances are, if it was active at the time the memory was acquired, we would see some sort of network artifacts relating to that connectivity, right? So to do that, what we'll do is go into sys, and we'll go into net. And within net, you'll notice that we have netstat.txt and netstat-v.txt. A lot of times you will see files that have -v at the end, which is going to be a more verbose version, or at least I think that's what the -v stands for, but it's a more verbose version of the information. So netstat-v.txt is going to have more information than netstat.txt. But honestly, either one would get us to the correct answer. We can just go with netstat.txt. And if we go ahead and scroll down through here, what we're doing is we're looking for connectivity that we would consider anomalous. Now let me zoom out a bit so this fits on the screen without wrapping. And if we look for any kind of established connections that we have, that's going to probably give us our best clue. So for example, you can see an established connection right here. This is not the correct answer. This is just a internal to internal 445 or SMB connection. But what we're going to be doing is looking for any kind of external connectivity that we would consider anomalous. And by the way, I am seeing some things that are immediately catching my attention here. Like, for example, what is this with port 8888? I certainly don't recognize this. We would need to look up that IP address and see what it is. But keep an eye on the right side here. As I'm scrolling down, I am seeing right here dwagent.exe. I happen to know that dwagent and dwservice is a commonly used remote access tool. So my bet is that this is the answer. And in fact, spoiler alert, it is the answer. dwagent.exe is the remote access tool that's in use here. And now, again, how would you know that? I would scroll through the list of network connections, and if I didn't know what DW agent was, I would Google it, and I would very quickly arrive at the fact that that is a remote access tool, and that would be the answer to the question. So dwagent.exe. And again, you can see all the information associated with that right here. And let me just highlight all of that for you. You can see the IP address there on the right side, along with port 443, which is being used for those comms. And that's all there is to it. So dwagent.exe is the remote administration tool. Okay, let's close that. Once again, go back to the root and move on to the next question, which is, what is the earliest execution time of the remote administration process running on the system? Remember, we already know it to be DW agent. So how will we find that answer? Well, one way is to go back into sys and to actually go and look at the processes, which you'll find under proc. And under proc, you'll see proc.txt and also proc-v.txt, but proc.txt will work just fine. Once again, I'll zoom out a bit so it fits on the screen. Notice that we have this nice hierarchical format, kind of like pstree or windows.pstree and volatility, if you're familiar with that. I really like the way that this is displayed here. It makes it very easy to visualize parent-child relationships. Okay, so it's asking us for the time. So what I would do is go ahead and do a Control F and search for DW agent. So let's type that in. And as you can see, we do have a tree right here. Notice that we see DW AG SVC. I guess that's DW agent service, perhaps. And underneath that, we see DW agent. We're being asked for the earliest execution time of the remote administration tool itself, which is really just going to be the dwagent.exe that we're asking for here. And notice that we do have the timestamp right here as 16:33:30 on 2024-0818. So that is going to be the answer, 2024-0818, 16:33:30. That is the earliest execution time or the start time of that process for dwagent.exe, which we had identified in the previous question as being the remote administration tool in use on the system. And that's one way you could answer this question. Again, as I said earlier, this is not the only way to arrive at that particular timestamp. I'm just showing you the more direct method or the easier method that I would use to approach this in a real world type of scenario. Okay, so let's close that. And now let's once again go back to the root of M and on to the next, which is question number 8. Around the time of compromise, the threat actors utilized a file transfer tool to download a malicious binary. What is the name of this tool? And it gives us the format as something like rdpclip.exe. So they want just the name of the binary, apparently. Okay, the way I would do this is actually go back into forensic, and then I would go back into CSV where we had those timelines. And there are going to be a number of different timelines that you can see right here. Now, you could look for a prefetch timeline, or you could look for an NTFS timeline, or you could look at timeline_all.csv, which is literally all of the timelines combined into one. In this case, let's just do that. Let's just open the giant timeline_all.csv file, which is going to have everything rolled up in it. Now, remember that we said the remote administration tool activity took place around 1630. I think it was 1633 to be exact. Now that we have timeline_all.csv opened, let's go ahead and click on the time column and make sure that we are properly sorted by time. And what we're going to do is look for 2024-0818 around 1630 in that time frame, because that's when we saw some of the activity. So what we can do here, you can see we're at the correct date already, is we can scroll down until we find something around 1630 in that time frame. So let me get to that point. And looks like I went a little bit too far. Okay, here we go. So let's scroll down from here and see if we see anything that might stand out as any kind of file transfer tool. Notice that we are seeing prefetch files right here, as you can see with the Smart Screen, for example. So what we're looking for might be in the form of a prefetch file, because we might find prefetch for whatever that tool is, whether it will be something like WinSCP or FTP or whatever the case may be. So let's keep scrolling down and see if we can find anything that might be indicative of a file transfer tool. What if we just go up to text here and actually filter on prefetch, which would get anything within the Windows prefetch directory? That might help us narrow things down a bit and make it easier for us to find it. And in fact, there it is. you can see curl.exe right here. Curl is a very commonly used file transfer tool, especially in the Linux Unix world. But you can see curl.exe right here. It's very similar to wget.exe or wget if you're familiar with that. But that is going to be the file transfer tool. Now, admittedly, it took me a little while to arrive at this answer because I started with timeline_all, and until I filtered it down to just prefetch to kind of narrow the data down a bit, it was a bit of doom scrolling looking for something that was anomalous. And, just note that there are some powerful filtering and searching capabilities built into Timeline Explorer, so use those to your advantage. We started with the master timeline all, but then we very quickly arrived at the answer just by filtering on the text of prefetch, which got the Windows prefetch directory. And you can see curl.exe right there. So again, the answer to the question would be curl.exe. That is our file transfer tool. And you can see that happening here for the prefetch creation time at 16:53:46, so that we know the time of execution is somewhere around that time, minus a delta of 0 to 10 seconds or so for that prefetching process. So there you go. Okay, so let's go ahead and close that and move on to our next question. We'll go back to the root here. And that next question is question 9, which is, what is the name of the malicious binary that executed roughly 1 minute after being downloaded? And it looks like it wants the format of just binary.exe, so whatever the name of the file is. Now, one way I would approach this is probably, once again, using a timeline. So I'll go into forensic, CSV. We could open timeline_all again, or we could just narrow it down a bit and just open timeline_NTFS to look at a file system timeline instead of the, I guess I'll call it the super timeline of timeline_all. In this case, let's start with just our file system timeline. So let's go ahead and maximize this. And what we could do is something very similar. We could filter on prefetch once again and look to see if we see any kind of suspicious executable around that particular time. Remember, we're looking at 2024-0818. And if we make sure that we're sorted by time and then scroll back down to that point, let's see if we see anything that stands out to us as something that might be anomalistic, like the name of a binary that we do not recognize. And actually, I am immediately seeing something right here. Remember, we had already seen a reference to Office Upgrade when we looked at netstat. There was some sort of netstat connectivity associated with a process named Office Upgrade.exe. And in fact, this is a prefetch file. You can see the creation of that prefetch file right here at 16:54:46. And notice the curl.exe that we found in the previous question is right there, very shortly thereafter. That's 16:54:09. So not long after that, we're actually seeing Office Upgrade.exe right there. Now, specifically, it said, what was the name of the malicious binary that executed 1 minute after being downloaded? This is the execution right here, right? This is the prefetch birth. So if we subtract somewhere between 0 and 10 seconds, we know the execution took place around right here. But now let's take off this filter, which we can either delete it completely by clicking the X or just unchecking the box. Doesn't really matter. But notice we're still on the same line. We don't know 100% for sure that this is the answer. We need to actually verify that. But check this out. If we go up from this point a bit, let's see if we can find the creation time of Office Upgrade. And I can see it right here on this line. Let me highlight it for you. So check that out. Both lines are highlighted now. 16:54:08, we've got creation or birth for Office Upgrade.exe with the interesting capitalization here, capital U, capital P, grade.exe. And it looks to be in the root of the drive. That's 16:54:08 for the creation. And then we have prefetch creation time at 16:54:46. So we know execution took place at approximately 16:54:46 minus that prefetch delta of 0 to 10 seconds. The question was, what was the name of the malicious binary that executed roughly 1 minute after being downloaded? Well, that's got to be it, right? That's roughly a minute after being downloaded, a little less than a minute. But there you go. Office Upgrade.exe is going to be the answer to our question in this case for question number 9. Okay, so let's go ahead and close this and move on to the next question, which is number 10. Let's go back to the root here. And number 10 asks us, the malicious binary used the registry for persistence. What is the full path of the registry key used for persistence? So it wants things like, HKLM/path. So how will we find that? One way is, once again, to look at a timeline. We can go into forensic and we can go into CSV. And this time we could actually look at a registry timeline. So if we scroll down, you'll notice there is a timeline_registry.csv. And if we double click on this to open it, we can actually go through and look for common ASEPs or auto start extensibility points that are common within the registry. And I'll bet you can think of one right now. I certainly can. That would be software, Microsoft, Windows, current version, run, and there's also run once. And remember, those locations are both under ntuser.dat, so under HKCU, and under HKLM for all users. What I would honestly do is actually go into text here and filter on run if I was doing this in real life. And let's see what we have. I do see a reference to software, Microsoft Windows current version run. And what timestamp do we have here? It looks like the last write time is going to be 16:54:25 on 2024-0818. Right in the middle of our activity, we see a reference to this. Do we see any other potential answer here? So again, before that, we do see some other references that have run in it. But just looking around this particular time, I don't see anything else that lines up quite like this. This is perfectly within the time frame of the activity. It is a very commonly abused, commonly used registry auto start point, and you can see it right there, current version run. So that is going to be the answer to the question. More specifically, HKLM software, Microsoft Windows current version run. That full path is going to be the answer to question number 10. Okay. So with that said, let's close this, go back to the root, and move on to the next question, number 11. What is the attacker IP address and port to which the malicious binary connected? I'll bet you can already think of where you would look for that. Let's go back into sys. Let's go into net. Let's go back into netstat.txt. And let's go ahead and shrink the text a little bit to make it fit. And what I'm going to do is do a Control F for Office up. And there we go. Office upgrade is right there. It's an established connection. And notice that the remote IP address is 64.23.144.215 with the remote port of 8888. So that is going to be the answer to the question in this format where you've got the IPv4 address, colon, and then the port. So the socket, in other words, that is going to be the answer to the question. Pretty easy to find. We had already known that that particular process was evil, and we can just use netstat to quickly arrive at that particular destination IP address and port. And there you go. Okay, so let's close that and go back to the root and move on to the next, which is question 12. What is the name of the malicious loader DLL that's injected inside the malicious binary? So that's a little bit of a different kind of question. But remember the find evil mode that we used? Well, that's probably going to be able to help us out here. What we can do is go back into forensic, but this time let's go into the find evil folder that's presented to us here. And notice that we have a findevil.txt file, and as a result of us accepting that elastic Yara rules agreement, we have a Yara.txt file. Let's go ahead and open findevil.txt, and I'll go ahead and zoom this out a bit so it fits on screen. Now, what we're looking for here, according to the question, is the malicious loader DLL that's injected inside the malicious binary. Notice that we have a type here where you can see things like YR_Trojan, driver_path. There's actually a type here that's going to be PE_inject. We do see PE_patched right here, for example, but PE_inject is going to show us any kind of process injection events that may be present. So what I would do is actually go back up here and just do a Control F for PE_inject. And it's actually right there. It was like on the first page. I didn't even notice it, but right there, PE_inject. And notice the module right here, coffloader.x64.dll. That is going to be the name of the malicious loader DLL that was injected inside of our malicious binary. Notice the malicious binary right here as office upgrade.exe. It's truncated a bit, but you get the idea. Right there, that is going to be the answer to the question as identified by the type of PE_inject. We can see our malicious process name here, and we can see the actual DLL file here, and that's all there is to it. So that's the answer to the question. And by the way, on the MemProcFS documentation, you'll actually find a page that contains all of these different types with a very easy to understand description of what that means. In other words, you'll find things like YR_Trojan, PE_inject, with a description of what it is that you're looking at there and what that means. So I'll leave a link to that documentation in the description here. So make sure to reference that because that's going to be your easiest way to find exactly what's going on there. We're almost done with our workstation image. Question number 13. Review the NTFS artifacts for other suspicious files created around the time of compromise. Can you locate the file name of the malicious script? Well, once again, I'm going to go back into Forensic, CSV, and in this case, if we're looking for a file creation or something like that, I'm just going to open up timeline_ntfs.csv, and I am going to look for file creations around that time frame. Now, notice that it did say a malicious script, right? Well, one thing that would lead me to believe is that I'm going to be looking for something that's a script that might have a script extension. Now, that's not necessarily true. It may not have a .vbs extension or something like that, but it may, so that's certainly something I could start with. Now, if we make sure that we're sorted by time, notice that we're on 2024-0818, and we already know the time frame in which a lot of this activity took place. Remember the 1600 hour, there was quite a bit of activity. So what we could do is go ahead and look for file creations around that time. And to do that, we could actually go under Action right here and click the little filter. And we could just filter on file creations only. And of course, notice that we're way back in time now. So we need to scroll all the way back down to the time frame of interest on 2024-0818 around the 1630 time frame, let's say. And let's just see if we can find any kind of malicious script. You know, at this point, we don't know if it's something like Python or Visual Basic, or we don't know what it is, right? But we do have our file creations. We're looking at it right here. So at this point, we could start scrolling down, looking for the creation of a file that might be indicative of some sort of script. Now, of course, we could speed this up a bit by going to text and just searching for things like .vbs to see if we have any matches. And in fact, we do have some. We've got things in Windows System 32, syswal 64. These, I am not completely sure what they are. We could also look at things like .ps1 for PowerShell. And notice that we do have quite a few hits here. So if we scroll down through here, let's see if we find anything that stands out. And notice that right here at the very bottom, in the root of the user's directory, we have a script called temp.ps1. I don't know about you, but that would stand out amongst all of these things pretty much immediately to me. If I found any kind of file named temp.ps1, so a PowerShell script, located in the root of the user's directory, so not even within one of the users, but just in the root of the user's directory, certainly not something that would typically be present there, that is actually going to end up being the answer to the question. Now, you may be thinking, well, wait a minute, hold on. How do you know for sure that that's the answer? Well, remember, we'll talk about this in a moment, but there is actually a way to look at a partial reconstruction of the file system itself. You can actually browse, much like we did with the registry, you can actually browse in one of two different ways under Forensic, a partial reconstruction of the file system. So you might actually be able to go through and find that particular script still on disk, and then open it and figure out exactly what's going on here. And guess what? That's actually going to lead us to the answer to our final question. So let's go ahead and transition into that final question, and then I'll show you how we can verify that this is indeed the script that we're looking for. Okay, so what we'll do is close this, and remember that's in the root of users within the C drive, right? So let's go back to M, and our last question is, what is the name of the malicious DLL invoked by the threat actor created script during the reflective DLL injection? Okay, well, let's go into Forensic. And remember, I told you there are a couple of different ways that we could browse the actual partial reconstruction of the file system. One way is under Files and then under Root. And here you can find that partial reconstruction of the file system. Or under Forensic, you can go into NTFS and notice that you have a 0 and a 1. The 0 is just going to have some NTFS meta files here, but the 1, which remember, this is a path you've seen referenced. In this case, remember we saw /1/users/temp.ps1, right? Well, let's just go ahead and drill down into there. So 1 is the representation of our C drive here. And if we go into users, check this out. Temp.ps1 is right there. Okay, so let's go ahead and open this. And this is not only going to verify what we thought was the answer to the previous question, but if we're right, it should help us answer this question. And as you can see, this script is indeed referencing Office upgrade.exe with the weird capitalization of UP. We already know this to be our malicious process right here in the root of C. So clearly this is our malicious script, meaning that the answer to question number 13 of temp.ps1 is spot on. But now this question is asking us the actual name of the malicious DLL that's been invoked here. And if you take a look at this, check it out. cmstp-uac-bypass.dll. There you go. There's the answer to our final question regarding the workstation image. So how cool is that to be able to actually open a script as if you're browsing a disk image due to that partial reconstruction of the file system based on the contents of memory? An absolutely amazing capability. Now, of course, you could do a similar thing with Volatility 3, for example, by extracting or dumping the files from memory. But just to be able to have the ability to browse the file system as if it were a disk image within Windows Explorer, just like we could with the registry, for example, that ability is absolutely amazing and one of my favorite things about MemProcFS. Very, very powerful. But there you go. There's the answer to our final question regarding the workstation. I hope you found the workstation walkthrough helpful. And now it's time to move on to the server questions. So let's go ahead and transition to that and see if we can answer those questions. Off camera, I ran MemProcFS against the server image using the exact same options that we used for the workstation image. As you can see, we're looking at the root of the M drive, and we're now ready to answer the first question for the server image. That question is, what is the PID of the malicious process? One way you could go about answering this is to look for network connectivity associated with the C2 IP address that we identified within the workstation image. That IP address, which I wrote down, is 64.23.144.215. So let's see if we can find any network-related information that might show a process associated with network communication to that IP address. To do that, we'll go into the sys folder, and under sys, we'll go into net, and then we'll open netstat-v.txt, which is the more verbose output for netstat. Let me zoom out a bit here so more of this fits on the screen. And then what we'll do is press Control F and search for the IP address. So I'll type in 64.23.144.215. And as you can see, we do indeed have a match. Let me scroll down a bit and I'll highlight the line on which this connection is noted, which is right here. It actually wraps, as you can see. And notice that the PID is actually going to be in the second column here, and it's 4544. So PID 4544 is associated with a network connection to the IP address that we just searched for on port 8888, and it's associated with the binary name of rgarterny.exe. This is indeed our malicious process, and it is indeed PID 4544, which is going to be the answer to our question. I'm actually going to keep this file open because we're going to be using this same information to answer the next question, or at least partially. Question number 2 is, what is the full path and file name of the malicious process? Again, full path and file name. Now, technically, we can get some of that information here. Notice that if we take a look at the very last column, we have /device/hard disk volume3/windows/temp/rgarterny.exe. But notice that the answer to the question wants the format of drive letter, like C:\\. Now you could make an assumption that this is indeed C:\\Windows/temp, and you would actually be correct, but how would you be able to verify that? Because it's not necessarily a given that Windows would always be installed on C:. Well, let me show you a couple of different ways that we could go about gaining additional information. I'll close this and go back to the root of the M drive here. And the first thing we're going to do is go into PID, and then we're going to go into 4544, which was the PID that we just identified. And within this location, let's take a look at two different files. The first file that I want to show you is just called win-path.txt, and you can see it right here. If we open win-path.txt, unfortunately, we still don't see a drive letter. We see the same information that we just obtained with netstat-v.txt, and that's still helpful and good to know, but what if we still need to find that drive letter, which we are assuming to be C? Well, that's where we can look at another file, which is right here, called win-cmdline.txt. And if we open this file, notice that we do indeed see c:/windows/temp/rgarterny.exe. So what I've highlighted here is indeed the full path and file name for the malicious process, and that is going to be the answer to question number 2. Okay, moving on. Let's go back to the root of the M drive. And question number 3 asks us, what is the parent process that spawned our malicious process? This is going to be a 2-step problem. First, let's go back into PID and back into 4544, which was the malicious PID that we had just identified. So we'll go into here and notice that we do have a file called ppid.txt, and that is going to be the parent PID. If we open this file, we can see that that is 648. So we know that 648 is the parent PID that spawned this PID, but how do we get the actual parent process name? Because we're being asked for that in this case. And the answer is, as you might have guessed, pretty simple. All we have to do is go back to PID, and then we can go into 648, which is right here. Once we enter that particular folder, all we have to do is scroll down and find name.txt, which is right here. And as you can see, the name is services.exe. So services.exe is associated with parent PID 648, and that is the answer to question number 3. So let's close that and go back to the root of the M drive and move on to the next question. That question is, what is the name given to the persistence mechanism created to launch the malicious process? Now, again, there are multiple ways you could approach this, but when I think persistence mechanisms, I'm going to start with low-hanging fruit. I'm going to think services and scheduled tasks, both of which are often used for persistence. So let's just start with services. If we go into the sys folder, within sys, we're going to find a folder called services, which is right here. If we go into services, we have a file called services.txt, which is going to be a nice summary of all of the services. And you probably already know where I'm going with this. Now let me zoom out a bit once again so more of this fits on the screen. And all I'm going to do here is press Control F. And this time what we're going to do is just search for the binary name for our malicious process, which is rgarterny.exe. When we search for that, we do get a hit. And if you scroll down and take a look at what we have, you will notice that we have Office Upgrade Service. So that is the service name right here. Let me zoom in so you can see it. Office Upgrade Service. So essentially, we have a service that's been created called Office Upgrade Service, and it has a bin path referencing our known bad process, which is right here. So the answer to the question is Office Upgrade Service, and it is indeed a service which has been created as the persistence mechanism to launch the malicious process. And that's the answer to question number 4. Let's close this and head back to the root of M and move on to question number 5. What is the command line used by the child process of our malicious binary? Now, to answer this question, what I would recommend doing is going into the sys folder and then going into proc, which you can see right here. And then we'll have a file called proc-v.txt, which is a verbose output of our processes. Once again, if we zoom out, we're going to be able to see the process list here. And this is actually being presented to us in a tree-like pattern. So we can actually see parent-child relationships here. Let's go ahead and go back up to the beginning of the file. And now let's think about how we can approach this. You probably already have a general idea. All we're going to do, once again, is search for the name of our malicious process, which we just searched for. And that's the rgarterny.exe file name. If we press enter here, notice that we do indeed have a hit. And if we scroll down a bit, let's take a look at what this is showing us. This is the process itself, and you'll notice that it's PID 4544, which we already knew to be the case. But if you look under this, you will notice that you see PowerShell.exe, which is PID 2404 with a parent PID of 4544, meaning that this is a child of this process. So PowerShell.exe is the child process that you can see right here. But we're being asked for the command line used by that child process. Because we've opened the verbose version of this file called proc-v.txt, we actually have that right here. Let me highlight it for you. This, which I've just highlighted, is going to be the full command line of our child process for the malicious binary. And you can see it right here. It starts by invoking the PowerShell.exe binary, and it ends with the UTF-8 string that you can see right here. So that full command line that I've highlighted is indeed the answer to the question. Okay, let's go ahead and close this. We'll proceed back to the root of M and move on to the next question. And that question is, take a look at the malicious process. Can you identify a specific file path it used for persistence? Now, this might be a bit more tricky when you think about how to solve it, but it's actually not that hard. All we need to do is go into the PID folder, and from here, let's go back into 4544, which is the PID of the known malicious process. And one way we could go about solving this is to look at handles. If we go into handles, we'll actually have a handles.txt file. And what we can do is take a look at the handles associated with this process to see what, in this case, registry keys or files or other things that this process may be interacting with, which might point us to a file path being used for persistence. Now, if we scroll down a bit, it's not hard to see, but notice right here, we actually have a path that's pointing to hard disk volume 3, which we know to be C:users, administrator, app data, roaming, Microsoft, Windows, start menu, programs, startup. That's actually a very well-known path. That is the start menu startup folder for this specific user. So it is a user-specific auto start extensibility point associated with, in this case, the administrator user. So that is going to be the answer to this particular question. This is going to be the specific file path that was used for persistence. And again, the way we approach this is to look at the handles associated with our known malicious process, PID 4544, and this will show us things like files, registry keys, events, and other things with which this process is interacting, which in this case points us directly to what we need. And in fact, keep an eye on that path because that path is actually going to be needed for the very next question. And that next question is question number 7. Let's close this and go back to the root of M. And question number 7 says, the file path identified in the question above was used for persistence for a second binary. What is the name of the binary? Well, one easy way we can determine this is try to see if this might be within the on-disk recreation that we saw within the forensic folder. Remember, within forensic, we have files and NTFS, which are two different representations of the file system as it's been reconstructed based on memory, which is pretty awesome. So what we can do is just traverse to that very path. So let's try it. What we'll do is use files in this case. So let's go ahead and go into files. And once we're in files, let's go ahead and proceed into root. Then we'll go into users. Then we'll go into administrator, then app data, roaming, Microsoft, Windows, start menu, programs, and finally startup. And notice that we have traversed to the same location that we just identified in the previous question. And as you can see, we do have what looks like a binary being referenced here. And that binary is officeupgrade.exe, spelled with the capital U and P. We've seen this before, and that is indeed the answer to question number 7. That is going to be the second binary located within the administrator's start menu startup folder. Let's go back to the root of the M drive once again. In fact, I'll just click on this PC and go back to M instead of clicking back many different times. And now let's proceed to the next question, question number 8, which is, what is the name of the persistence tool that the threat actor attempted to use? This is a more advanced question. The way you're going to solve this, or at least the way I would recommend going about it, is to go back into PID, back into 4544, and this time you're going to look at a mini dump. Notice we have a folder here called mini dump. This is essentially a dump of the process memory associated with this process. All we need to do is run strings against minidump and actually just grep or search through the output of those strings looking for the answer to this question. Now, in the interest of time, I'm not actually going to do this here. I'll leave that as an exercise for you just to keep this video at a reasonable length. But again, if you run strings against minidump.dmp and take a look at what you have, maybe try searching for known persistence tools or even something with the word persist in it, you're going to find the answer to this question, which is going to be a program called sharppersist, spelled SHARPERSIST, sharppersist. And again, the best way to go about approaching this, at least in my opinion, is to run strings against the process memory for our known malicious process and just look through those strings to see if you can identify anything of interest. Okay, let's head back to the root of M and proceed to the next question, number 9. That question is, what C2 framework is in use on this device? It turns out this is actually very easy to determine because we used the -forensic option when we ran MemProcFS. Remember that option? Remember I told you that it automates a lot of low-hanging fruit checks for us? Well, not only did we use that, but we also used those built-in Yara rules, and really either one would point us to the answer to this question. But for our sake, let's just go into forensic, find evil, and here we have findevil.txt. And as soon as we open findevil.txt, right at the very, very top, you will see YR_Trojan. So it's been detected by a Yara rule. And notice that it says multi_Trojan_sliver. Sliver is indeed the answer to the question. This is the C2 framework in use. This is similar to something like Cobalt Strike, if you're familiar with that. So Sliver is indeed the C2 framework in use within this particular memory image. And we found that just by opening findevil.txt, and that was very easy to pick out because remember, we used the -forensic option and we also used the option to include those built-in Yara rules to scan the memory image. And that's all there is to it. So let's close that and go back to the root of M. And now we're down to our last 2 questions. Question number 10 is, what is the name of the earliest file staged for exfiltration by the threat actor? And this is going to be very easy with a file system timeline. So what I would do is go into forensic CSV. And if I were you, I would just open up timeline_ntfs.csv, which is going to be essentially a file system timeline for this particular image. And what we can do is take a look at this file system timeline, make sure that we're looking around the time frame of interest and see what we can find here. So once this loads, I'll go ahead and maximize it, and we'll make sure that we're sorting by date and looking for that particular time frame of interest. So I'll go over to the time column and make sure that we're sorted here. And I'll give you a second to stare at this, but the answer is going to actually be right in front of you on this particular machine. Remember, this is a server. In this case, it's a domain controller. And among the most common files targeted by threat actors on domain controllers would be what? That's right, ntds.dit. Now, if we look down here, we will actually see on line 24 in this case, a CRE or creation event for this particular file. So you can see CRE right here, and you can see a timestamp right here, which in this case is 2024-0818 at 180456. So that is going to be the timestamp in which we're interested. And in fact, we could go and browse the file system or the recreation of the file system as we just did to see if that file is still on disk, which will be pretty interesting. But notice that timestamp. And of course, if you look right below it, well, spoiler alert, that's going to lead you to the answer of the next question. And that next question, and final question in this case, is the name of the second file staged for exfiltration. And that file is going to be system. Notice that both of these are going to be located in the root of the file system. We have 4 lines total because notice that 2 of these are for creation in this case. So really, this is the creation and this is the creation. And those are really the 2 specific lines that we're interested in. We've got 180456 and then 180607 for system. But those are the 2 timestamps associated with the 2 files that were staged for exfiltration. And in this case, that is actually going to be in the root of the C drive. Remember, we had the /1 and /2 when we look at the recreation of the file system underneath NTFS. So both of these are actually going to end up being in the root of the C drive. And as you might imagine, ntds.dit and the system registry hive have no business being located in the root of the C drive. That is not a standard location. That happens to be where our threat actors staged them, and the order in which they were staged, once again, is first ntds.dit and then system. Both of those files will be necessary if you were to decrypt the encrypted hashes within the DIT and then try to proceed forward to crack those hashes. Those are the two files you would need, and that is the answer to our final question for this challenge. And with that said, that wraps up everything I wanted to show you in the walkthrough of both our workstation image and our server image. This was a fairly in-depth memory forensics challenge, but as I think you'll agree, using MemProcFS really does help you get to the answers straight away. You could, of course, use Volatility 3 or other memory analysis frameworks to try to answer these questions, but in my opinion, MemProcFS is certainly going to be an option that is very, very quick, and it's usually where I'll start. I like to think of this tool as being something of a magnifying glass for memory forensics. If I need a microscope, if I need to go really, really in depth, then I might resort to something like Volatility 3 or even Volatility 2 in some cases. Or if I want to go even deeper than that, then maybe WinDebug, which I could open by taking the memory.dump file here, which is already in the proper Windows crash dump format, and I could carry that over to WinDebug and go even deeper if I wanted to go to that level. But I think that's really all I wanted to cover in this particular 13Cubed episode. I hope you enjoyed this walkthrough, and I hope you learned a lot from participating in this XINTRA Lab. Thanks for watching, and I'll catch you in the next 13Cubed episode.